Welcome to Eggs and Issues, a monthly business forum presented by the Portland Community Chamber of Commerce, bringing timely economic discussion to the region for nearly 40 years. Thank you to our sponsors and partners. Presenting sponsors, Bank of America and Martins Point Healthcare. Cooperating sponsor, Harvard Pilgrim Healthcare. Reception sponsors, Clark Insurance, Key Bank, and Viral. Community Corner sponsor, Goral Palmer. Tomorrow's leaders and entrepreneurs sponsors, AAA Northern New England and ProSearch. Coffee sponsor, Skowhegan Savings. Parking sponsor, Vitalius Real Estate Group. Media partners, radio sponsor, WGAN. Print sponsor, The Forecaster. TV sponsor, WMTW Maine CW. Business news sponsor, Maine Biz, with production support provided by Headlight. And thank you to our special community partners, Anthem Blue Cross Blue Shield, MEMIC, Spectrum Healthcare Partners, Southern Maine Community College, and the University of Southern Maine. And now, please welcome Portland Community Chamber President, Britt Vitalius.
Good morning. It's a little dark up here. I think I'm going to be able to see my notes. Welcome to the March 2022 Eggs and Issues program, the monthly business breakfast event series of the Portland Community Chamber of Commerce. As we continue the 2021-22 Eggs and Issues season, I would like to welcome everyone joining us today in person and to those who are participating virtually. We took a couple months off for Omicron, but with the numbers subsiding, we're back in person and very happy to be here together. My name is Britt Vitalius. I'm the president of Vitalius Real Estate Group, a boutique real estate brokerage in Portland, and I'm honored to serve as the volunteer president of the Portland Community Chamber of Commerce. Today's topic, Shaping Maine's Scientific Future, will be presented by Dr. Hermann, president of MDI Biological Laboratory, that's MDI BL. I have to admit that when I first heard that we had a lab in Maine researching whether or not it was possible to regrow missing limbs, I was a bit surprised. I did a double take when I learned that it was happening right on Mount Desert Island in their biological laboratory in Bar Harbor, Maine. Growing limbs, really? What exactly does that mean? So that's an attention grabber. And I've since learned that MDI BL has a long history, 125 years, of doing very important science that affects all of us here in Maine and beyond, from diagnosing and treating kidney disease to understanding how to prevent the onset of age-related diseases. But before we begin our presentation, I would like to share our appreciation to each of our sponsors of Eggs and Issues who make this event possible, whether we are in person or virtual. First and foremost, Bank of America, Martins Point Healthcare. I also want to thank our generous sponsors, our cooperating sponsor, Harvard Pilgrim Healthcare, our reception sponsor, Clark Insurance, Key Bank, and Viral, our Community Corner sponsor, Goral Palmer. Today's Community Corner is the American Lung Association. Along with the great work ALA does throughout the year, they are proud to announce this year's 38th annual Trek Across Maine. This multi-day, 180-mile cycle event, June 17th to 19th, begins and ends at Thomas Point Beach in Brunswick, with overnight stops at Bates College in Lewiston and St. Joseph's College in Standish. All funds raised by trekkers support a range of lung health programs. Please join us to welcome members with us today from the American Lung Association. Today's leaders and entrepreneurs sponsor, AAA Northern New England and ProSearch. Through this program, the Chamber can offer students in the region, high school and college, an invitation to attend Eggs and Issues at no cost. With us today are students from USM, SMCC, and Falmouth High School. Please stand and be recognized if you are here with us today. That's my favorite part. I love that you guys are here, so thank you for coming. Our coffee sponsor, Skowhegan Savings. Our parking sponsor, Vitalis Real Estate Group. That does not mean I'm going to be valeting your car. But and a special thanks to our media partners, The Forecaster, WGAN, WMTW, Maine CW, and Maine Biz. Our For More Information sponsor, our FMI, is Portland Public Library, and production support is provided by Headlight Audiovisual. And we've returned to the Holiday Inn by the Bay this month. It's great to be able to resume meetings in person today. For those participating remotely, please know that we have been able to gather safely each month since September. We took a couple-month hiatus for Omicron, but we're back. And our policy has been to require a negative proof of vaccination or negative test, and increase the distance at the breakfast tables and seats to only 5 per table. Masks are optional this month. We hope these restrictions will continue to be decreased as we go forward. Looks like hopefully the wave is behind us, and it's just so great to be here together. Finally, a very special thank you to our special community partners who support all of the Chamber initiatives: Anthem, Spectrum Healthcare Partners, University of Southern Maine Community College, and MEMIC. Let's have a round of applause for all of our generous sponsors. Before we begin today's program, I'd like to welcome the Chamber's newest members. We are a membership organization, and we are only as great as the businesses who choose to support us. So I'd like to invite any future members who are with us today to consider joining. We know you'll enjoy our programming and many other member benefits. The Chamber's membership is truly as diverse as the Portland region's business community. Now, onto today's topic, shaping Maine's scientific future. As a reminder, like all Eggs and Issues programs, we'll be recording the event, which will be available at the Chamber's YouTube channel. For those joining remotely who are streaming the program on YouTube, please submit any questions for our presenter in the chat. If time allows, we'll incorporate audience questions following the presentation. And if you have any additional questions following today's presentation, you are welcome to send them to the Chamber at chamber@portlandregion.com. Today's presentation will provide a glimpse into the decades of groundbreaking research in the field of tissue and limb regeneration. We are also going to learn about the recent announcement of MDI Bioscience and their work on increasing efficiency in drug discovery while utilizing non-mammalian models. Today's presentation is by Dr. Hermann Haller, the president of MDI Biological Laboratory. Dr. Haller received his medical degree from the Free University of Berlin and completed his postdoctoral work at Yale University. He has published more than 700 peer-reviewed articles, holds 6 worldwide patents, and has founded 4 biotech companies. He travels back and forth from Maine to Berlin, where he has a lab working on kidney disease, and is also a full professor and chairman of the Division of Nephrology at Hanover Medical School in Germany. I think he stays busy. Dr. Haller just returned from an international conference in Boston, where he and his colleagues launched a new drug development initiative at MDI BL aimed at creating new partnerships with pharmaceutical companies that strengthen Maine's technology sector and its workforce. We're very excited to have him here today. This is going to be really great stuff. Dr. Haller, please come join us.
Good morning, everybody. Thank you very much for the opportunity to be here today and to tell you about MDI-BL, about the past, but most importantly about the future. We strongly believe that we are part of Maine's future. Thank you very much for the very kind introduction. There's actually nothing more to talk about. But I want to introduce you to Mount Desert Biological Laboratory. And you already have heard that we have a long history. We are part of Maine's history, 125 years. But although I can't see everybody, how many of you know about MDI-BL, Mount Desert Biological Laboratory? Thank you very much. That's on the one hand very disappointing. But on the other hand, if I would have seen more hands, then it would have been totally unnecessary to come here. So this shows you the lab. We are on Mount Desert Island, and together with the Jackson lab, we are better than Manhattan. We have more scientists per square foot than New York City on Mount Desert Island. We have been founded, can I have the next slide, please? 125 years ago in southern Maine, Harpswell, Tufts University, and then when Acadian National Park was founded by George Dorr, he considered science to be an essential part of Maine and the natural beauty on Mount Desert Island, and he invited the lab, and we moved there, and we are relatively small, but we have 200 acres around us, 250 acres with lots of cottages, and this is what gives us the opportunity to be a place where we can invite the world for science on Mount Desert Island. We have a long history of international collaboration, and I'd like to introduce you a little bit to our science, what we actually do there, our educational programs, and how we contribute to the future of Maine by educating the young people in Maine and also further south. And last not least, I will talk about MDI Biosciences. Jim Strickland is with me today, and the two of us, we have started this initiative. Courageous, we'll be successful, and I'll tell you why we do this and what it means both for Maine and for drug development. Here you can see our buildings. On the right-hand side, you see our educational building where we run lots of courses, and I'll talk about that. And on the left-hand side, you see research. Down by the water, you can see our old labs, which we are at the moment restructuring to have more space for visiting scientists. Very small in between, but very important, is administration. So we are very much research orientated, and Jerry Bowers is with me today, who is organizing all this. There's not a lot of space for administration. We all use it up for animals and for science. Next slide, please. We have a long history. We have not only a long history of science, but also of discoveries. You see here just a few of our alumni and a few of the discoveries. Margaret Lewis, 1918, she learned how to culture cells in Berlin at the Charité at that time, brought it to MDI and started cell culture. This was one of the first places in the US. We have a very strong history in kidney research. You see here Homer Smith. Homer Smith is a legacy, and every kidney doctor on the planet knows Homer Smith, who has been president of MDI-BL for 10 years in the 60s. He actually made significant contributions, and we still measure kidney function, and we describe kidney function with the discoveries which have been made at MDI-BL. And you see others, Frank Epstein, editor of the New England Journal from Boston, who spent his life, most summers of his life, in Maine, and Boris Schmidt-Nielsen, very important physiologists. But not only kidney and renal and transport, but also cancer. You see here Dr. Karnofsky, who in the 50s and 60s developed the modern strategies how to treat cancer at MDI-BL. This is a long history, and we're working very hard to make this more known in Maine, but this is now enough history, and I'll talk about where we are now and about the future. Next slide, please. So, who are we? And we are our science. But we make our science, as you can see here, and this is one of the researchers looking at a zebrafish. And after my talk, I hope that I make you understand what zebrafish are for and what our other animal models are for. Next slide. We're small. We have 11 research groups. The 11 research groups, however, run independent laboratories. So each of these research groups is famous, and our junior research groups are becoming famous. And that's the idea. We want to have something like 15, 16 research groups. Each research groups 10 to 15 researchers, technicians, students. And this is the core of MDI-BL. So it's quality, not quantity. We want to be internationally known for the quality of our research. You can see there that we are doing quite well with fundraising. We are number 3 in the state of Maine in getting funds from NIH. So the National Institutes of Health support the Jackson Laboratory, and we, as I said, are number 3. Next one. We are an international community. I already mentioned our campus, which is not only beautiful, but provides us with the opportunity to invite scientists from other parts of the world. We have a very strong collaboration with Germany, not only because of me. I came there because of this collaboration in the 90s, but this goes back 30, 40 years. For a while, every kidney researcher in Germany was at MDI-BL for at least one summer. We're having now a visiting scientist program where we try to integrate these international scientists into our research. So this is unique. We can form these collaborations, and they not only take place via the internet and discussions we have together at meetings, but they actually come to MDI-BL. And this provides then, as you can see here, an international community. Sometimes you hear more French spoken at MDI-BL or other languages. So we have researchers literally from all corners of the world. Next one. And very important, we train students. We have trained students for decades. We have one example. One of our board members was originally a student 30 years ago, and he didn't become a scientist or a medical doctor, but he went into banking. But nonetheless, these were important years he spent at MDI-BL. I'll come back to this at the end of my talk, because I think besides the science and besides the entrepreneurship, what we are starting right now, the education of young people, and to make them understand what science is, to train them with the most advanced methods so that they can make educated decisions what to do with their lives. Next one. And entrepreneurs. I already mentioned Jim Strickland. We also have a long history here. One of our first patents was so successful that it's still supporting our visiting scientist program at the moment. And this was Tom Marin in the 70s, very successful patent. And now we are trying to link this with the latest development, and this is MDI Bioscience. Next one. Next slide, please. Before I come to this, let me briefly explain our research. What are we actually doing? We are seeking answers to complex biological questions, and mostly in aging, research, and in regeneration. Next slide, please. Is it possible to delay the onset of age-related diseases? We are asking these questions not in humans that much, but we are trying to understand the mechanisms, and therefore we're using C. elegans, that's a little worm, that's a classical model for aging research. And recently we have introduced African turquoise killifish. These are African fish, and unfortunately their lifespan is only 8 months. because this is the time they have in Africa before everything dries up. So we are trying to make them live longer, and we try to understand how lifespan is regulated. We also want to understand how we can live longer better. So we understand what contributes to disease when you become older. And we just recently published a very interesting paper where we, for the first time, could identify that the noise of our genes becomes louder. They don't work that specifically anymore. So this is the type of research we're doing in aging research. And next slide. Can we repair and regrow damaged organs? This shows you a kidney. And you can see with one glimpse, this is complicated. That's not easy. You can't do this in one afternoon. But we are trying several approaches. We use stem cells from patients. We can actually scrape your skin, take one fibroblast, turn this fibroblast into a stem cell, your stem cell, and then we can differentiate from this one stem cell all the cells which are necessary to make a kidney. One of the major challenges is then to put this all together, like always in life. And my specific area is the vasculature. What you can see here in blue, I want to understand, and this is what my research group is doing, how the blood vessels actually go into an organ and supply the organ with the blood and the oxygen and the nutrients the organs need. Very complex, very challenging, but we do this using stem cells, but we also use our animal models because they teach us how this is happening. And we have a long history in kidney, but we have started with other organs, regeneration. Next slide, please. Can we regrow missing limbs? And this also tells you how fast we are at MDI Bio. To be honest, 5 years ago, we have one research group. Now we have 2 research groups. And at the moment, we are having these animals. I'll talk about this in a moment. The largest facility for axolotl in the US. Next slide. So this shows you an axolotl. These are masters of regeneration. All our animals can regenerate, but they can regenerate their limbs. So you know they are from Mexico originally, but we have now 1,200 of these animals in our basement, and we are growing at the moment. And we study, next slide please, how they regrow a limb. So this shows basically an amputated limb. And here you can see these animals can, within a couple of weeks, regrow a limb. This is what we want to achieve in humans. But before we can do that, we have to understand how, with muscle, with blood flow, with nerves, with skin, with everything which we need for a functioning limb, how this works. And this is what we're doing at MDI Bio. Next slide, please. And we do this in a very original fashion. So to answer the question, can we regrow missing limbs? We have research groups investigating the role of the immune system. We are among the first to understand that we need immune cells actually for regrowing a limb. This doesn't come naturally. This needs a lot of research. And one of our research groups is looking into interstitial tissue. Interstitial tissue means this is the stuff which fills your limbs. And for a long time we thought, this is totally secondary. But it turns out it's very important to structure a limb. So this is groundbreaking research we're doing at the moment. And you can see below that some of the tools we're using for that, and I'll come to this in a minute. Next slide. We also do regeneration in zebrafish. I've already mentioned this, kidneys, but also muscle, retina. We're looking into the vascular system at the back of the eye, and this is damaged in diabetes, for instance, and we understand the mechanisms of eye disease in zebrafish and how we can repair this. We are very good, next slide please, with technology. Our imaging technologies, I'm very proud of that. We have now the best microscopes on the East Coast. At the moment we are building one microscope they don't have in Boston. And this allows us to monitor live what's going on in our animals. We have to generate animals which are fluorescent, so that we can actually see blood vessels grow and we can see nerves. And this is what we are using these microscopes for. Next one. Here you see our axolotl early on. So this shows you how wonderful this is. And first of all, this is important because we understand in a living organism what's actually going on. When you do this in a dish, when you use cell culture, then this is also fascinating, but you may miss some of the important mechanisms in living tissue. We do obviously genetics, but we are also very strong in bioinformatics, and I'm happy that in Portland we have now with the Roux Institute an initiative which makes Maine unique in the area of bioinformatics. And then, next slide please, we are using now this knowledge and our techniques and our animal models. You mentioned non-mammalian animal models. Most people don't know what non-mammalian means, but non-mammalian means that we have animals which we can use very early on in their development, and we don't have to use that many other animal models in the future. So yes, mice are still very important, but it's better to have smaller animals earlier on in order to make decisions. And this is what we offer for our research, but we also offer it to pharmaceutical companies and to biotech companies. Some of the smaller biotech companies, especially in the state here, when they start, they have intelligent people, they have a good concept, they may have a patent, but then when they have to test this using animal models, this is where we come in. They can call us, we are helpful, we are building under the leadership of Jim Strickland facilities where we can fulfill all the criteria, the regulatory criteria, so that we can use our animal models not only for science, but for the FDA in order to get drugs approved and accepted. Now, which diseases? Why is this important? Next slides. 500 people lose a limb in the US. That's a lot of patients who would really need our research in order to regrow a limb. We are very good with prosthetics, but it would be much better to be able to regrow completely or at least partially skeletal tissue. We are working, next slide please, on chronic wounds. Most of you are aware this is a big medical problem. In diabetes, diabetics suffer from chronic ulcers and they are very hard to heal. And this is our research with new blood vessels, with new skin. And next one, this is my area. I'm a kidney doctor. And we have 37 million people with chronic kidney disease. We have just developed the first drugs to treat chronic kidney disease, but at the moment we only have 2 on the market and so many patients. 90,000 patients in need of a transplant, and I've been responsible for one of the largest transplant programs in Germany for a long time. So I understand transplantation, but MDI BL is now opening the the science and hopefully the medicine in the future for new organs. And 20,000 transplants performed each year. This will still go on, but perhaps we can use our patient-tailored kidneys in the future. Next slide. So as I mentioned, MDI Bioscience is offering this. Next slide. And to quote Jim Strickland, we know that only 1 in 5,000 drugs make it to the market. That's very important because it means that when you have a new drug and only one drug makes it to the market, you have to find out very early on that this drug won't make it. And this is what Jim understands, and this is what we are offering, that using our animal models, you can make early decisions. And to quote you again, to fail early. That's what you have to do in drug research, and then only take the winner and go on. So MDI Bioscience seeks to develop new tools to help drug companies efficiently and confidently identify the molecules with the greatest potential to improve the lives of patients. And as I said, we are very open. When you here in the Portland area, but also on the East Coast and internationally, we offer our services and we offer our knowledge. So it's not only the tools, but it's also the scientists that we can sit down together and think about the problems and come up with solutions. Next slide. We have a lot of international collaborations. This is not our visiting scientist program, but I've been in drug research for a long time. Next slide. This shows you the list of our existing collaborations. You may be astonished. Northeastern Maine, and these are the international collaborators, and you see some of the major drug companies there, but also a long list of small drug company, biotech companies, and some of them are from Canada, some of them are from other parts of the world. And these days, it's relatively easy to start these collaborations and to help them and to do research together. Next slide. We are building and have been very successful over the last couple of years, statewide partnerships, not only in research with the University of Maine, but also here in Portland. We have close collaborations with Maine Medical, with the Research Institute. We're looking forward to collaborate with the Rue Institute, and we had our first meetings to talk about specific projects. I've started to teach at Kobe entrepreneurship, or how to start a biotech company, and this is very fruitful. It's great to get to know more about Maine. And last not least, next slide please, it's our students. Shaping the future of science in Maine means that we have to train young people. And MDI-BL has a long history. Next slide please. We have started the Maine INBRI program more than 20 years ago, and we are coordinating from MDI-BL the biomedical education in the state. We have 14 partners from Presque Isle to Portland. We have 170 million in federal grants. 55 scientists are working within this program, and we have trained more than 3,000 students over the last 20 years. And that's the future. And perhaps this is, besides entrepreneurship and besides our science, our most significant contribution to shape the future in Maine. Next slide, please. So I've talked about our research program. I've talked about our international research program. I hope that after this morning, when I ask you the question, do you know about MDI-BL? You may say, well, I have a vague idea. Somebody was talking about that for 25 minutes. I've talked about our education programs, and most importantly at the moment, together with Jim Strickland, our translational research, MDI Biosciences, and last slide. Thank you very much for your attention.
Whichever you like. So now we got a few more minutes. Am I on? All right. Thank you. Thank you for being here, for introducing us to MDI BL. Maine has a lot of hidden gems, and this one is particularly special. My first question is, because this is a business breakfast meeting, I've got to come at it from a little bit of the business angle, is what are your challenges in terms of your own workforce development and attracting qualified people to Maine and to where you are? Clearly, the aesthetics of where you are must help.
It does, in a way, but still, I mean, northeastern Maine, that's far away. I mean, the challenges, as you know, are considerable. When we talk, a technician working in New York City, Columbia University, is interested coming to Maine. We are on the phone. You know what they pay at Columbia for a technician? This is beyond our means. So that's one challenge. Housing is a big challenge on the island, but also in the county. It's not easy to recruit people. So a significant amount of work goes into that, but we were successful. We have recruited serious scientists from Europe, moving them with their families to the island. So I'm very proud that we have now a strong community there. But the problems are still high. We have to find work for the spouses. I mean, all the problems you're facing here in Portland as well, this is what we have, and even more so on the island. So recruitment is tough, and we spend a lot of energy.
Oh, not just in Portland. It's interesting, yeah. What does the science tell us about aging, and what are the most important things we can do in our lives to slow down the aging process? We'd all love that.
Yeah, that's a great question, a wonderful question, the $1 million question. We should have some of our aging researchers here, and they would talk now for the next 45 minutes without stopping. At the moment, our research is concentrating on metabolism and aging, and the answer is relatively easy. At the moment, our evidence and a lot of people's evidence show that the less you eat, the longer you live.
That's terrible.
I know. However, there is hope. So, but in between, like intermittent fasting, we have done very exciting research that the body shifts then the energy consumption, and you actually reactivate when you have early dinner and late breakfast. In between, you have a shift in your gene regulation, which is beneficial. And I'm not talking about this drug, but there are now new drugs out there, especially for diabetes treatment. And we have a very interesting collaboration where we look whether these drugs, which have been originally developed for diabetic research, whether they have an effect on aging, because they bring the body into a state of intermittent fasting.
I'm not sure I love that answer. I'm not going to ask about alcohol.
We could talk about that, you know.
How about hair growth? Are we working on hair?
Hair growth, very interesting. The side effects at the moment are still considerable, but we have new drugs for that. And then we all agree red wine is beneficial for
Good. Good. This is just such fascinating stuff, and I'm just so excited to look 25, 50 years out. And where do you see, and my next question was about regeneration and organ growth. Can you talk a little bit about that? And then I'm going to ask you sort of what it looks like.
Yeah. So first of all, it's fascinating research. I mean, to understand how organs regrow and what the mechanisms are behind that, that's interesting, and that's what we're doing for a living. However, in order to push this forward, you have to be practical. So the US has, the NIH has a wonderful initiative growing a new kidney. And there we use all sorts of approaches. You know, I mean, silk, for instance, for a fabric to bring the cells together and to make new kidneys, decellularizing matrix and making new organs. So we also are into biotech, really changing that. And then eventually, to make this successful, this is, you need industry for that. I mean, it's not done having one kidney made in a lab and it takes 4 years. We're talking mass production.
I want to thank you for the gummy fish, by the way. My kids are going to be very excited to hear about this. Looking 25 years out, 50 years out, what do you see, or what should we expect to see? You know, science is fast and it's slow sort of at the same time, like a lot of technology, and we hear about regrowing limbs and growing organs. When should we expect to see this kind of thing? What do you think the future looks like?
As you know, that's a very complicated question. What we're doing is, I mean, human suffering will not go away. However, like the medications we have right now makes it easier. We have antibiotics, we have drugs, and we are developing at the moment a lot of new drugs to heal specific conditions. So that's one answer. We will be better in healing or ameliorating conditions such as diabetes, wound healing, etc., what I just mentioned. Your question was when? You know, tomorrow. Not tomorrow. And there are two answers to that. One is serendipity. You never know. I mean, the breakthrough may come from an angle totally unexpected, and we have seen this in science all the time. But on a time scale for kidney, where I'm more the specialist, I would say 5 years we have a functioning kidney. Depending on which approach we choose, at the moment I think the best approach is that we transplant into an already failing kidney some new tissue and then let it grow there. So that's one approach my lab is working on, transplantation of renal tissue into an existing kidney and not going and you shop for a new kidney. And so this will be 5 years or so. To have brand new kidneys, more like 10, 15 years.
Wow, that's incredibly exciting and incredibly soon. And that's not 50 years. That's
yeah, but this is, as I said, the NIH has a program. Internationally, we are collaborating. There are a lot of people working in this area.
That's great. That's great. I want to open it up to questions from the audience. We've got a couple of mics here, and I don't know if we're able to see questions from our virtual audience or not. But if anyone has a question, please come up for Dr. Haller.
Thank you so much for coming today. Clearly I need help with my eyes, so I hope you're working on eyesight. I'd love to hear a little bit more about the benefits of the early drug development that you talked about.
Yeah. When you look at how long it takes to make a new drug, most of you are aware this takes 10, 15 years. So the drugs we have now on the market, this started a long time ago. And in the early stages, and this is what I was talking about, you have to make important decisions. And the longer this goes, the more costly it is. So a lot of money goes into early drug development in all the cell culture studies, in all the animal studies. And our contribution is to be more specific, to have genetic models where we can actually test the mechanisms very early on, and to have models where we can look for toxic effects of the drug, so we can early identify whether a new drug with a fascinating mechanism has a negative effect, for instance, on the gut
or the liver or the blood-brain barrier, and then we can identify this, and then we can stop that. And this is very important. I have started several drug companies, and the agony now that you have side effects and you're not 100% sure whether these side effects will then eventually destroy the drug or whether you'll be able to. This is where we want to have an impact and where we want to contribute. And this is especially important for young, small biotech companies. When you have a drug, you need partners where you can sit down and say, well, let's talk about the experiments we need in order to find out not this drug, but perhaps another compound. And Jim and I, we were talking to fascinating young companies. They have 6 drugs, totally different, and they have 6 groups really pushing these 6 projects forward, and we can help them then to eliminate perhaps one and concentrate on the others.
Good morning. Thank you for coming. This is fascinating. I'm Paula Mahoney from Words at Work, a marketing consulting firm here in Portland. I remember going to visit your lab as a little girl when we were on vacation in Bar Harbor. My mother dragged us around to all sorts of strange places. And I remember mice and other, I think monkeys. Could there have been monkeys in the 60s? I don't know. Anyways, my question. Science has brought us lots of things into our everyday life. Will there be a time, do you envision a time when instead of knee replacement, we regrow our bad knee or our bad hip or our arthritic knuckle, which is really bugging me today? So could you talk about that a little bit? Is that 1 generation, 2 generations, less?
I think the time frame is about the same I just described for new organs. Because, for instance, your knuckle, that's, as we know, inflammation. And we would like to regrow the cartilage, less blood vessels, more cartilage, and we are working on that. So when you look at our axolotls, I mentioned briefly interstitial tissue. This is collagen, this is cartilage. We have identified a cell type which actually makes new cartilage. And we are all fascinated about the cell type because, for instance, in sports, repairing Achilles tendons, that will be fascinating. So I think to turn on these specific cells in specific tissues, that's not that far away.
Wow. Cool. I'll sign up.
We'll have a sign-up sheet here available to anyone who wants a new kidney, limb, or...
So how many new kidneys do we need, actually?
You're very well attended this morning. This is why.
Good morning, and thank you for joining us this morning. I think it's so fascinating and exciting. I am a high school educator, and I have some students here with us today. And I'm curious if you could talk a little bit more about how students would get involved in your laboratories, and if you would welcome high school students to come up and see what you're doing.
Yes, we love high school students. In our experience is just wonderful. It's not only that they come and see what we're doing, is we involve them in the research. Our summer courses, you really start in the lab. You have a project, you have good mentors, and we know how important that is, and then they do their own projects. I'm very proud, one of the high school students in my lab last year, you walk into the lab during the summer at 9 o'clock in the evening, and this girl is sitting there pipetting a PCR protocol just because she's so interested to see the results. And so we believe very strongly in bringing them into science very early on. It's challenging, we know that, and it's demanding, but I think it's also very rewarding for them, and since we can throw in the natural beauty in our campus and a whole program. The mix is good. But as I said, very early on, exposure to lab work with mentors who make you understand what you're actually doing.
The application process is on the website.
Yes, Jerry just reminded me, on our website, applications are there.
That brings me sort of a nice segue to something I wanted to ask about, which is you're in Maine, you're sort of been tucked away here for 125 years, and now many of us are learning about you for the first time. How would you like to be better integrated into the state, or I guess what other connections would you like to have with the state of Maine? You already have such international connections, you can kind of be right there and also be interacting with the world. Local students is one. How else can the business community support what you're doing?
Well, if you remember us from my talk this morning and from the information material we provide, that you know that we are there, that you have an idea of what we are doing, and then we form connections like that. And we're doing quite well. I just mentioned this over the last 3 years. We have been very active. We are getting more integrated, and it's great to be here, and it's great to talk about MDI-BL here, and we'll hope that this will have an impact.
That's great. Tommy.
We have a question from those attending virtually. This is from Miles Robert. Talking about the discovery of salmon DNA in trees suggests interesting interconnections in our environment. Is it accurate to say that is it DNA, or is it a more accurate way to describe that phenomenon?
Yeah. First of all, thank you very much for the question, because it gives me the opportunity to talk about toxicology. We have a very strong interest in toxicology. In the 70s and 80s, we had an NIH-funded toxicology program. We were involved in several animal species. We are the wardens of Frenchman's Bay together with others, and we are protecting the environment. We are also using our animal models for toxicology, environmental toxicology. So we are developing fish, and they change the color when they are exposed to certain toxins in the environment. We have to talk about specific projects, but toxicology is very important.
We probably have time for one more question, if anyone has anything else they'd like to pose to Dr. Haller. Can you talk just a little bit about these small animals? You're able to not use mice a lot, and I think I saw something was on your website, or a little bit of research I was trying to do, that we share so much of our DNA in common with these animals that it allows you to do this kind of work.
Yeah, thank you very much. They're very important. You know, mice look like us, so we have more of the feeling they are better models. A zebrafish and you share 82% of their genes. And when I cut the kidney of a zebrafish and I look under the microscope, to be honest, most scientists cannot tell the difference between human glomerulus and a fish glomerulus. So there is a lot of genetic and structural homology, and this is what makes it so useful to use our animals. Now, the Jackson Lab is next to us. We collaborate. We have faculty, and they work with mice and work with what we call non-mammalian animal models. Our history is not monkeys. I'm sorry about that. This must be a wrong memory. I'm almost sure that we never had, at least not for scientific reasons, monkeys on campus. However, we started with the ocean. You know, this is why we are originally a marine biology lab, because in the 19th century, with Darwin and the whole history about evolution, sea animals were so important. So this is our legacy, this is our history, And then we changed into genetic animal models, so they're still watery in a way, but it's mostly the genetic homology with us, which enables us to use them as models for drug development.
It's amazing. Maybe they just bring out the monkeys when the kids come, so that years later they come to an event like this because they're thinking they monkeys?
No. I mean, now we are getting into the specific. We don't need monkeys. I can tell you, most kids fall for axolotls.
Good. Well, I think that probably concludes our program. So, Dr. Haller, thank you so much for being here. I really appreciate it. You can stay here.
Thank you.
Such a sincere thank you for being here with us today and sharing your time and providing a glimpse into this amazing little corner of our world in Maine at the MDI BL. As we conclude today's program, you can view a complete list of all the Chamber's upcoming events at the Chamber's website, which is portlandregion.com. And we encourage you to subscribe to the Chamber's newsletter and be sure to follow the Chamber across all our social media platforms. We look forward to seeing you next month, hopefully in person. It looks like things are looking good. It's going to be April 8th at our next Eggs and Issues event. We'll hear from our panel of policymakers, employers, and advocates who are in addiction recovery. They'll discuss the importance of building recovery-friendly workspaces to address the state's workforce shortages and the positive impact this can have on our community. Thank you all so much, and have a great day.
Thank you.
Thank you.
Thank you. It was a pleasure. Thank you. Very nice. Thank you.